Look up at the sky, and the sun seems eternal. But stars are living things in cosmic terms. And yes, the sun is slowly growing older. The big question, can we actually see it? The sun, that brilliant star at the center of our solar system, was born about 4.6 billion years ago. That might sound incredibly old, but in the grand cosmic timeline, it means our sun is roughly middle-aged, about halfway through its expected lifespan. It's currently in its most stable and predictable phase, a period that scientists refer to as the main sequence. This is the long, peaceful prime of its life. During this main sequence phase, a powerful and continuous process is happening deep within the sun's core. Under immense pressure and at temperatures reaching millions of degrees, hydrogen atoms are being fused together to create helium. This nuclear fusion reaction releases a tremendous amount of energy, which radiates outward, travels across space for about 8 minutes, and finally reaches us as the sunlight and warmth that make life on Earth possible. It's this steady, reliable burn that defines the sun's character right now. However, this process isn't static. Over immense stretches of time, the composition of the sun's core is slowly changing as hydrogen is converted into helium. This has a subtle but significant effect on the star itself. Astrophysical models and observations of similar stars have shown that for every 100 million years that pass, the sun's luminosity increases by about 1%. While a 1% change sounds trivial and is far too slow for us to ever notice in our day-to-day lives, its cumulative impact over geological timescales is profound. This gradual brightening will eventually have dramatic consequences for Earth's climate, slowly raising temperatures and altering the conditions on our planet's surface over hundreds of millions of years. So, can we actually perceive this aging process? The simple answer is no. A human lifetime is a mere blink of an eye compared to the billions of years the sun takes to evolve. The changes are happening on a timescale so vast and slow that they are completely invisible to us. The sun we see today is, for all practical purposes, the same sun our earliest ancestors looked up at. But just because we can't see it happen in real time doesn't mean we can't understand it. Scientists use incredibly sophisticated stellar models, which are like complex computer simulations of stars, to predict how the sun's properties will change over time. Furthermore, they study other stars scattered across the galaxy. By observing stars of different ages and masses, astrophysicists can piece together a complete stellar life story, from birth in a stellar nursery to a dramatic death. It's like being a cosmic detective, using the light from distant stars as clues to reconstruct the past, present, and future of our own sun. And what does that future look like? The models predict that in approximately 5 billion years, the sun will have exhausted the hydrogen fuel in its core. When this happens, its stable main sequence life will come to an end. Without the outward push from hydrogen fusion, gravity will cause the core to contract and heat up, igniting a shell of hydrogen burning around it. This new energy source will cause the sun's outer layers to expand dramatically, transforming it into a colossal red giant. It will swell to such a size that it will likely engulf the inner planets Mercury, Venus, and possibly even our own Earth. After this spectacular phase, the sun will shed its bloated outer layers into space, creating a beautiful, glowing planetary nebula. At the center of it all will be the sun's final remnant, a small, incredibly dense and hot core known as a white dwarf, which will slowly cool and fade over trillions of years. So no, we can't see the sun age, but science shows us that it's slowly ticking toward its grand finale. The universe is a storyteller, and the sun's tale is still being written across the cosmos.
Stay curious.